everyone. Today we are looking at the topic water, and we will specifically look at water distribution. So in this topic we will look at how water is distributed around the earth, and also what role water plays as a solvent. Now if you don't know what a solvent means, you will definitely learn it from this lesson. So first up, we will look at the three things: solute, solvent, and solutions. So we will look at what these three terms mean and also how water relates to these three terms. So you can do this experiment at home. So what you can do is you can take a glass of water and you can pour salt in your glass of water. Now when you do that, when you stir your water after you put the salt in, you will see that the salt crystals are disappearing. Now this is what we will look at more in detail. What is the chemistry behind dissolving the solvent? So first up, because salt is the substance that we are dissolving in our water, it is referred to as our solute. And because water is the substance that is dissolving the salt, so the salt is actually disappearing in water, so water is dissolving the salt, and therefore we call it our solvent. And the solution that we form, which is a salt solution, so when you do this experiment, you will actually find that you get a clear solution, and that clear solution is called a solution. So your salt water will be a solution. So let's look at these three terms in more detail. So in more general terms, for example, so what is a solute? A solute is a substance to be dissolved in a solvent. And what does that mean? If you remember from the previous slide, you dissolved the salt in water, and salt is the substance that went into the water and disappeared. So that would be our solute. And what about a solvent? A solvent is a substance, usually a liquid, but not always, that is used to dissolve the solute. And if you remember, your water actually caused your salt crystals to disappear. That means your solvent in this experiment will be water, because it is the substance that is used to dissolve the solute salt. And the solution that you get from this mixture is your salt solution, the salty water, which would be a clear solution when you conduct this experiment. And the definition of a solution is a homogeneous mixture formed when the solute dissolves in the solvent. Now what does homogeneous mean? Homogeneous means uniform mixture. Now how does that relate to our solution? So if you look at this picture, the color of the whole solution is a bit white compared to your initial water. Now a uniform mixture means that only not parts of the solution are white. It's not that only a bit of this solution is white. You can see the whole thing turned the same color. So when you look at it in real life, it will look at one whole solution. Not only parts of it will be colored white. The whole thing is colored white. That means it's uniform throughout its composition. So throughout this solution, the salt crystals are flowing throughout the solution. So the whole thing is uniform. And that's what a solution is. It's a homogeneous mixture. And also, because if you remember, I said that solution does not always have to be a liquid. So just because when you think of a solution, you think of water, does not mean that only water can be the only solution. A solution can also be an alloy. Now, you should know what an alloy means, but what is an alloy? An alloy is a mixture of metals. So it is different types of metals joined together. And if you remember, an alloy is usually a solid. So it's a solid solution. And also air. So air is present in our gas state, but in air, you know that there are different types of gases joined together. For example, the oxygen you breathe, the nitrogen plants use, the carbon dioxide plants use, that's all in air. So air is actually a mixture of gases joined together. Now let's look at the fact that what if we mix two things together but they are the same state? So for example, you can think that you're mixing two liquids together. Now, when both of them are same state, how can we tell that whether it's a solute or a solvent? Now, that's what we will look at in this part. So when both the solute and the solvent are in the same physical state, for example, a liquid state, the solute is the substance that is in smaller quantity than the solvent. Now, what does that mean? For example, in the diagram, you can see that you mix ethanol and water together. So you put ethanol and water in a test tube, and in your test tube, ethanol is of lower content. So you have very much less ethanol in your test tube compared to the amount of water you have. Therefore, your ethanol will be your solute and your solvent will be water, because as the definition states, solute is the substance that is present in smaller quantity. And in my example, I said ethanol will be in smaller quantity, so ethanol will be our solute. Now let's look at what kind of substances dissolve in water. So ionic compounds dissolve in water. So if you can remember, ionic compounds are substances that are present as ions in your solution. So what are ions? So ions are charged particles. For example, in the diagram you can see sodium and chloride ions. Sodium has a charge of +1 and chloride has a charge of -1. And these are ions. So when you put salt, such as normal table salt, which is sodium chloride, when you put that in water, they will be present as salt solutions. They will be present as ions. So they will be present as sodium ions and chloride ions. So that's what this means. So water can dissolve ionic compounds. It can also dissolve covalent molecular compounds, for example, some gases. It can also dissolve solid molecules. So it can dissolve a sugar molecule. A sugar molecule is not present in the form of ions. It stays by itself. So it will always be C6H12 or 6. It would never be a carbon ion, a hydrogen ion, or an oxygen ion. It will stay itself as a molecule. So that's what it means. So water can also dissolve solid molecules, and it can also dissolve ions involved in biochemical reactions in living things. So in our body, water is also present as a solvent, and in our body, for example, we have potassium ions and sodium ions that has functions with our nerve cells, and those ions are also dissolved in water solution in our body. Now let's look at some common examples of solutes, solvents, and solution. So first up, let's look at a copper sulfate solution. So as the name suggests, in a copper sulfate solution, you will have copper sulfate as your solute and water as your solvent. So what you do is you take some copper sulfate solid and you put it in water and it should disappear. And that means that our solute is copper sulfate and our solvent is water, which is dissolving the copper sulfate. And we get a copper sulfate solution as our product. Again, if you dissolve carbon dioxide in water, what solution you will get? You will get a soda water, and that is actually your soft drinks. So when you drink soft drinks, it is actually some water and carbon dioxide and some coloring put in your solution, which is soda water. What about ethanol? Well, now you can see that only water is not the only solvent we can have. Ethanol can also act as our solvent, and it can dissolve methanol, for example. And together, when you mix methanol and ethanol together, and also note that these both are present in liquid forms, these are both alcohols. See, when you mix these two liquid together, you can get methylated spirits as your solution. And again, petrol and oil both are liquid substances, and then if you mix them together, it will be two-stroke motor more fuel. So this will be your solution. And again, just to emphasize on the point, when you mix two solutions together, and if they have both same physical property, for example, if ethanol and methanol were mixed together and both of them are liquid, the one that is present in less amount is a solute. So in this example, methanol will be found in less amount because it says methanol is a solute, and ethanol will be present in more amount in your solution because this is our solvent, and together you get methylated spirits. Now let's look at the fact what aqueous mixtures mean. So aqueous mixtures always refers to when water is our solvent. So when you refer to aqueous mixtures, the only solvent that is possible is water. Ethanol is water. So ethanol cannot be a solvent in aqueous mixture. Only water can be a solvent in aqueous mixture. For example, when you write chemical equation and you write the state for sodium chloride in your chemical equation, what you will do is you write it like this. NaCl, and then you have the symbol Aq, which means aqueous. And what does that mean? This means that sodium is present in water. When we are looking at the reaction is actually occurring in water because it states that it's an aqueous solution. And that this also means that sodium is present as sodium ions and chloride ions in your water. So that's what the symbol aqueous means. So whenever you look at this symbol, always remember that the reaction is taking place in water. Also, it is often difficult to tell a mixture when solute plus solvent gives a solution, because if you remember, if you conduct the experiment of dissolving salt in water, it looks so clear that unless you taste pure water and salt water, you can't tell the difference from just looking at it which one has salt dissolved. So it is often difficult to tell what your solution is when a solute and a solvent is mixed together. Now let's look at why the soluble solid is not visible in water anymore. So when the soluble solid dissolves in water, what happens is the particles of the solid spread out throughout the whole composition of water, and so the solution appears clear. So as you would know that salt particles are very, very small, and when you put them in water, all of them, they don't stay together anymore, because when they're staying together initially, that's why we can see them as solute A, as one particle, so we can see them. But when you put them right into the water, all of them spread out. They spread out in equal amounts across the whole mixture of water, and therefore at the end we cannot see the salt particles anymore, because the water solution becomes clear as the particles spread out. They're not together anymore, and therefore they're more hard to see with naked eye. And the only thing we can see is clear water solution, and we can't see the solid particles anymore. So for a dissolving substance, the forces of attraction between it and the water molecules must exceed the forces between the particles of the substance. Now what does that mean? When you have the sugar by itself, there are forces holding the sugar molecules together. That's why you can see it like this. That's why you can see the white solid crystals in a sugar, because the forces are holding them together. But when you dissolve in water, the forces between the sugar molecules break. Also, the forces between the water molecules break. And what happens is the sugar molecules and the water molecules form their own force, their own new force, which is a new type of attractive force. For example, they can form dispersion forces between them, and that's why your solution dissolves. So for a solution to dissolve, you need to break the bonds between the sugar molecules that they initially had before they were put into the solution. And then when you put them into the solution, those initial attracting bonds break between the sugar molecules, and they form new bonds with the water molecules. So that's how a substance dissolves in a solution. So in this part, we looked at the three very important terms, solute, solvent, and solutions, and we also looked at how water is a very important solvent. Now let's look at some questions to test your knowledge. So let's look at some questions to test your knowledge. So first, our question asks us to define some words. So the first one is a solute. So what is a solute? If you remember, a solute is the substance to be dissolved in a solvent. So let's go back to our example of dissolving a salt in water. So when you put salt in water, salt is the substance that is dissolving, hence salt will be a solute. So a solute is the substance to be dissolved in a solvent. What does a solvent mean? A solvent is a substance, usually a liquid, that is used to dissolve the solute. So in our salt and water experiment, when you put salt in water, water dissolves the salt. Therefore, water is our solvent because it is the substance that is used to dissolve the solute, which is water. And what does solution mean? So solution is the homogeneous mixture formed when solute is dissolved in the solvent. So again, going back to our first example, when you dissolve salt in water, you're forming a solution which is salty water. So salty water is our solution. And why is it a homogeneous mixture? Because we looked at the fact that when you put a solid substance in a solvent, the molecules spread out evenly throughout the whole composition of the substance. Therefore, the whole mixture is homogeneous. There is never the chance where only a part of the solution has the solvent, but the rest of it doesn't. So the solid is spread evenly throughout the whole solution. Hence, it's a homogeneous mixture. So our solution is always a homogeneous mixture. So let's move on to question 2. Question 2 is a multiple choice question. So this question asks you, which of the following is not a solution? So be careful that in this question they're mentioning the word not, because we're usually in a habit to find the right answer, but this time you have to find the wrong answer. So let's see which one is not a solution. So our first one says brass. If you remember that a solution does not always have to be a liquid, so a solid substance can also be a solution. So what is brass? Brass is an alloy of iron and nickel. And what is an alloy? Alloy is a mixture of two metals. And again, it's a homogeneous mixture of iron and nickel. So brass is a solution. So A is not our answer because we're looking for something that is not a solution. So make sure you know the word not is mentioned in this question. So let's look at what is a salt water. So this is from our example, and if you can remember, salt water is a solution which has salt and water mixed together. Therefore, B is not an answer again because it is a solution. What about air? So air is a gas, but again, still, it is highlighting on the point that although it is a gas, it is still a solution. So a solution does not always have to be a liquid. And why is air a solution? Because it contains a mixture of different elements. So it has a mixture of different gases. So you have nitrogen gases, oxygen gases, carbon dioxide, argon. So you have different types of gases mixed together in air. Therefore, air is also a solution and hence not our answer. So what is our answer? Our answer is milk. And why is milk not a solution? Because to form milk, it comes out as pure. For example, when you're milking cows, you're not adding anything to produce the milk. It comes out by itself. So you're not dissolving some solid particle in the water to form your milk. It is a pure substance. Therefore, milk is not a solution, and our answer is C. Now let's move on to question 3. Question 3 asked us to give us 2 examples of water as a solvent in the natural system. So again, be careful that it says 2. So if you only put 1, then you will definitely lose marks. So make sure that you have 2 points in this question. So in the first part, we can see how water acts as a solvent in plants. So if you can remember from junior science that plants carry out a process called photosynthesis, where they make glucose molecules that is stored in them as starch. But this reaction takes place in their leaves. But how does it go to different parts of the plant? So if the reaction only occurs in the leaf, it has to go to the other parts such as the stems and the roots. So what happens is the glucose molecules are dissolved in water. So again, water is acting as the solvent in your plant. So the glucose molecules get dissolved in the water, and then the water transports the glucose molecules to the stems and the roots. Therefore, water is acting as a solvent in the plant, and it has a special name when it is acting as a solvent in the plant, and you call it aqueous sap. So when water is acting as a solvent in plant, we call it an aqueous sap. Now let's look at what function water has as a solvent in our body. So if you know, we all know that we breathe in oxygen and we give out carbon dioxide. But how does that oxygen travel to different parts of our body? So if you know that oxygen is bonded to hemoglobin molecules, and hemoglobin molecules are bonded to red blood cells. And as the name suggests, red blood cells are found in our blood. Now if you know that blood actually contains 90% water, so therefore your oxygen molecules are dissolved in the water, which is blood, plasma, and then they're carried to different parts of the body, such as the different cells, so that they can carry out their metabolic reactions. So, and also carbon dioxide. So when the cells carry out their metabolic reactions, such as respiration, our waste product is carbon dioxide, and we want to get rid of carbon dioxide from our body. So what happens again is the cell gives the carbon dioxide to the blood, and then blood, as in blood plasma, which contains 90% water, takes that carbon dioxide and brings it back to our lungs, where we breathe out the carbon dioxide. So as you can see, water acts as a solvent in our body because it is the main content in our blood plasma. So both carbon dioxide and oxygen are dissolved in water, and then they are carried to the different parts of our body to be used or to be excreted. Now let's look at question 4. Question 4 tells us to identify the sphere in which water exists in the solid, liquid and gas phase. So we need to look at different spheres of the earth, and we need to identify, which means remember, which of the sphere contains water in each of the 3 states. So if you can remember, in atmosphere water exists as a solid, such as snow or hail. It also exists as a liquid because clouds are actually liquid droplets of water combined together. That's why you can see them, because it is lots of liquid droplets of water combined together. And when they get too heavy, that's when you get your rain, because they break down and they form water. They do not form water droplets, so the water droplets just drain out of the cloud. So that's why liquid droplets are found in our clouds. And what about gas phase? So you know that we have water vapor in our atmosphere. So hence, water exists as 3 different states in our atmosphere: as solid, hail or snow, as liquid droplets in clouds, or as water vapor in the gas phase. Now let's look at our last question, question 5. Question 5 tells us to identify 3 different roles that water plays in human. So make sure you know that it's asking for 3 roles. So you have to mention 3 different things, and also it tells you to identify it, which means you do not need to describe, you just need to list the 3 different points. So first up, we know that water plays a major role as a transport system in our blood, because we have already looked at the fact that oxygen and carbon dioxide, for example, are dissolved in blood plasma, which consists of 90% water, and then they are carried to different parts of the body to be used or to be excreted. Hence, water acts as a transport system in blood. It also acts as a lubricant in fluid of joints, and it also acts as a coolant in evaporation of sweat. So when you are sweating, your hands get wet because it's actually water. And how is a coolant? Because your sweat evaporates, and that's what cools you. Because the sweat on your body evaporates over time, that's why the temperature of your body decreases if it's too hot. And that's how it acts as a coolant. And lubricant means that it causes, it helps your muscles or bones to move swiftly, so it's not too tight. This brings us to the end of the question session. In this topic, we looked at water and how it plays major roles in different parts of our body and also in other living things, and the major role of water as a solvent.